This is Will with SRT Amplification, and welcome back to the bench. Today I've got three things on the bench that I want to show you that I just got in the mail within the last week or so. And I call it my headliners and my opening acts and my headliner. So we'll take a look at the two opening acts first, and then we'll look at the headliner. A little bit of backstory about this first item. Back in the 90s, I was working as an industrial electrician for a company. I was also in the National Guard back then, before I went active duty Army. And my civilian job, though, while I was in the National Guard was for this electrical contractor who did a lot of automation and controls and stuff for oil companies out in the oil field, and gas companies, natural gas plants and stuff like that. So we did a lot of SCADA systems and stuff like that. But anyway, it was back in the early and mid 90s, and I had a truck and a helper, and we were always wanting to listen to music, but a lot of the places we had to work was up in the panhandle of Texas and Oklahoma and Kansas. Sometimes we were away from where we could pick up a station, driving and everything. So I had this CD player, and I had some powered speakers, battery operated speakers, and we'd sit that in the truck because there was only an AM FM radio in the truck, you know, and this is before MP3 players or anything like that. So I found this FM transmitter, and I bought it. I think it was at Walmart, and I put it in the truck, put my CD player in it, tuned to a frequency or whatever, and boom, it was right over the radio, right over our radio. So we did that for a while, and then one day we had these bag phones. This is before people actually had cell phones unless you were rich. But our boss had each truck outfitted with these bag phones, and plugged into the cigarette lighter, right? And we weren't supposed to use them except for extreme emergencies, or we needed something from him or something, out on the job site or something. But anyway, we had this big job going on, and there was about three of us electricians that were all going to this one job. So before we took off that morning from the shop, I told him, I said, hey, I want to be broadcasting on whatever frequency, tune your radio to it, and let's see how far this thing can go. And so he takes off, and anyway, it ended up being about a mile, because he was at 1 mile marker. He called me on the bag phone, and just real quick, and said, hey, I'm at mile marker whatever, and I was at mile marker whatever. So he was a mile ahead of me, and he was still hearing the, I think I had ZZ Top's Greatest Hits CD or something like that. Anyway, so let's get to this first thing. Let me adjust the camera here. So this is the first thing that we have on the bench. Let's get these out of the way. So I came across this FM transmitter. It's much like the one I had, except for this is a lot fancier. I think the one I had only tuned to one specific frequency or something. I don't know. I don't even remember how it worked. But this one you can tune to any frequency you want, up or down. It's got a mic input. It's a 3.5 millimeter jack. On the back, it's got the AC adapter input. It's got an audio input for like your CD player, or MP3 player, or something like that. It's got this BNC connector for antenna, and of course your adapter here, and your auxiliary cable. So what I plan on doing with this thing is I'm starting to work on receivers and radios now. So I can just mount this somewhere on the bench or something, plug my MP3 player in it, or my cell phone into it, or whatever, and broadcast right here, have my own little radio station. I don't know how far this thing will go. I don't remember mine back in the 90s having this nice antenna like this. Man, this thing's sweet. It goes way out there. But so yeah, I'm gonna see how this works. And this is going to be something that I'm going to be using on the bench in future videos. By the way, I've got a lot of repair videos in the pieces and parts of repair videos that I still have to edit and get put together, and those are coming. It just takes so much time to do repair videos because I'm working around the camera and everything and trying to get shots and stuff, and it takes so long to edit them all. And I've got a lot of footage. I just got to get it all edited. It's so much easier for me to do, a video like this because I can just talk about stuff and then it's pretty much one take. But anyway, that's all coming down the pipe. I also have a HP oscilloscope. I think it's a model 1220. It's coming in the mail soon. I've never used. I'm pretty much a Tektronix guy. When it comes to old analog scopes like this, that's kind of what I'm used to. They kind of have the same architecture and everything, so I'm pretty used to that. Even their digital scopes are kind of set up the same way, and then many of the digital scopes that are made today kind of use that same architecture. But this one's a totally different architecture, totally different layout. I'm gonna have to get used to it, but I'm gonna be putting that on the channel as well. Okay, so for the next opening act, maybe adjust the camera here. I have this EICO model 1140, and it's a resistor and capacitor substitution box. Now I have built some of these in the past from kits. Let me show you these ones I use up here. Right there. I built those from a kit. You can buy them online. They're really cheap. And I use those a lot, especially like in filter circuits and stuff like that. But what I thought was cool about this, not only the fact that both the capacitors and the resistors are in, I'm missing a knob here on one of the resistor selectors, but not only are the capacitors and the resistors all in one box, but you can switch this to put them in series or parallel with each other. So that comes in handy when you're doing filters and stuff like that, or bypass caps or whatever. So like if I have it in this position right here, series RC, whatever position I have the capacitor in will be in series with whatever position I have the resistor in, So in this case, you'd have a 0.047 microfarad in series with 1,000 ohms. So I thought that was pretty cool. And then you can also stick it over here and have put them in parallel. And then there's also a short function. Not sure what that does, except for shorts these two terminals out. And then there's the open function. We could test that right now to see if that actually shorts those two terminals out. I don't know why you would have such a setting on there, but maybe I guess shorting them out would discharge the capacitor if they're charged up. Maybe. I mean, that may be the reason for it. I don't know. But then why would you have an open as well? I'm not sure about that. But put this on continuity test here and see what this does. Yeah, so that just shorts out that out. Let's put this on capacitor real quick. I've got it on 0.047. I'll put this on capacitor check. And it's reading 4.64 nanofarads. So yeah, that's 0.047 microfarads. So that's pretty close right there on that one. Now, some of them are probably way off, but you only really need to get close with this, and then that kind of gets you in the ballpark, and then you can, do whatever you want to do with it. Let's see what the resistor reads, if it's 1000K or not, or 1000 ohms, I should say, 1K. It is reading See, that's only reading 218 ohms. 200, what do I have it here? Oh, I see. What's going on here? Resistors. Well, these are all reading off. Yeah, I'm gonna have to break into there and see what this. See, this thing's reading 1.2K, and I'm on. Oh, you know what? This knob may not be. Yeah, this knob is not pointing at the right thing. Wow, that is weird. So I'm gonna have to move that knob because it's not pointing at the right. It looks about right though. Let me get over here to. So there's 1.5. So that'd be that one right there. There's 2.25. That'd be 2.2K right there. So yeah, 4. Well, that says 3.3. So either they don't have the resistors mounted in here properly, or the switch is in here wrong, or something like that. I'll have to figure that out. But you'll be seeing this more on the channel. I'll be using it quite a bit when I start getting into the radio repair and the receivers and stuff like that. But I just thought that was kind of neat. It's the EICO model 1140 RC series parallel substitution box, and this is different than a decade box. A decade box would have multiples of 10 or multiples of increments of 10, and you could dial in any value you wanted with a decade box. And usually with a decade box, you're going to have one for resistors, one for inductors, one for capacitors, and they're fairly large, and they're probably going to have 4 or 5 different knobs per each thing, so you can dial in whatever value. But these are some of the common resistor and capacitor sizes that you're going to run into. So this is fine. And then you can always put combinations in series and parallel if you need a specific value or whatever. But that's it, the EICO model 1140. And now for the headliner. Got this a couple of weeks ago. Or I ordered it a few weeks ago. I may have got it last week. I don't know what this code 5063 is. Probably some inventory code. It probably came from a school or a university or a lab or something, and this was an inventory code. I have no idea. Really doesn't have anything to do with what this is, but let's open this up and look at it. All right, so this is made by SECO, SECO. I believe that stands for Specialty Electric Company or something like that. Can't remember exactly what it stands for. But anyway, here's the model 260 transistor analyzer. So, most of your meters, like your flukes and a lot of these, meters like... Okay, so I'm going to have to narrate over this. I don't know what happened with my video, but it got like into slow-mo speed or something like that. And so I'm actually speeding up the speed here on this video, but I couldn't get the audio to come out right. So sounded like either a chipmunk or an ogre. But anyway, basically what this thing does is it gives you more than just a beta test. There's also a dynamic test. It's got its own oscillator, or you can actually test in circuit with this thing, and the transistor under test becomes part of the oscillator circuit. And according to the manual on this thing, it actually SECO was the first to do this. It says this procedure was introduced as a first by SECO to the electronics industry in 1959. And I imagine this device was probably made right around that time, 59, 60, somewhere in there. It's about that vintage. But anyway, you can do in-circuit testing. It tells you how to do that on both signal and power transistors. This thing can also test all kinds of various different types of diodes, signal diodes, power diodes, tunnel diodes, Zener diodes, or Zener diodes if you want to call them that. That's typically how I say it. I don't know why I said Zener. Tetrodes, all kinds of stuff. It's a very versatile piece of equipment here. It also does various leakage tests, collector to base and collector to emitter. And
So yeah, it's a very versatile piece of equipment. And depending on where you have these little switches, whether it's in the signal mode or in the power mode, or whether it's in the 1000 range or the 200 range, for like your beta test, is going to determine what that meter reads. There's only two scales on the meter: 0 to 1000 on the upper scale and 0 to 200 on the bottom scale there. And that's basically direct reading for your beta or HFE tests for your gain, current gain. And then depending on whether you have it in the power or the signal for your various leakage tests, it's going to be a fraction of that, like 2 milliamps or 100 milliamps or whatever. The manual kind of breaks it down, but I will be using this on the channel in the future. I'm probably going to have to replace some of those alligator clips on those leads. But other than that, I'm kind of looking forward to getting this thing up and running. It's going to provide a little more versatility than just your standard, transistor tester that you have on a multimeter or something like that. So hopefully I'll be using it soon in some future videos and you'll see it. And that's it for the headlining act. So it was this. What I'm pointing out there is actually a sticker. This instrument was used by the Navy, is what the sticker says. So that may explain what that inventory code is on the front. I know the military puts their inventory numbers on everything. So, but that sticker says that this thing is not used for reference, so it doesn't need to be calibrated. So I mean, it would still be good for like matching transistors or something like that, or just to get a rough order of magnitude of how much leakage you have, whether the transistor is good or bad. But yeah, you're not gonna. Of course, with beta and HF, your current gain on a transistor is very dependent on temperature and all kinds of other factors. Temperature mostly. So you can just kind of get a rough estimate of what your HFE is for your calculations if you're putting together designing a circuit or something like that. So even your regular multimeters aren't all that accurate when it comes to HFE as far as that goes. But I appreciate you guys watching, and thank you so much. And if you haven't already, subscribe and hit the like, thumbs up, and hit that bell, and you'll get notifications. And look for more videos in the future. Thank you very much.